Assalamualaikum and hi student. Today we are looking at lesson 10. This video one of subtopic in alternating current. So we continue lesson 10 and the subtopic is resistance, reactance and impedance. So the the first one, sketch and use Phasor diagram and sinusoidal waveform to show the phase relation between current and voltage for a single component circuit of resistor and capacitors and inductor. Okay, first of all, we look at Phasor diagram. What is Phasor? Phasor is defined as a vector that rotates anticlockwise about its axis with constant angular velocity. It is used to represent a sinusoidal alternating quantity such as current and voltage, and it also being used to determine the phase difference between current and voltage in AC circuit. So this is a Phasor diagram. The left side is Phasor diagram, and then this is a wave. This is a sinusoidal graph. So the vector is rotating anti-clockwise. So this is the starting point here, and then rotate anti-clockwise. And then project to the graph, we get this sinusoidal AC waveform. So the Phasor diagram is the left side. This is the sinusoidal AC waveform. Okay student, let me start with resistor in AC circuit R. So this is a circuit. We have a AC signal. This one is AC signal, and then we connect with a resistor. So the current flow is the AC current, and the current pass through the resistor. So the voltage, the potential difference between the resistor is VR. VR is voltage drop through the resistor. So Phasor diagram, this is a Phasor diagram for the resistor in a AC circuit. So what is the Phasor diagram? Phasor diagram is a vector that rotate an anti-clockwise direction. So they rotate an anti-clockwise direction, and then projecting from this Phasor diagram, we can, on the y-axis, we can see the sinusoidal waveform, and we can get the sinusoidal waveform. So let me start with how the Phasor diagram can project it into sinusoidal waveform. Okay, this one is pure resistor, or the resistor only in AC circuit. So this is a current, and this is a VR, and in the resistor in AC circuit, the Phasor diagram, the current are in phase with the voltage. The current are in phase with the voltage. So we know that the Phasor diagram are rotate in anti-clockwise. So from projecting from this Phasor diagram, so this one is a graph V and I against time. So we know that here we start with 0 for current, and then when 90 degrees, the current is maximum, and 180 degrees the current 0, and then when the current here maximum but in negative direction, and then go back to the original position. So when we sketch this graph, we get the sinusoidal waveform, and then this is the maximum, I maximum or I naught, negative I naught. Okay, and then we look at the graph Phasor diagram for voltage. So here, this one is V0, this one is V0 maximum, and then 0, and then negative V0, and then go back to the original position. So when we sketch this graph, we get the sinusoidal waveform. So this one, the equation for VR is equals to V0 sine omega t, and for I is equals to I0 sine omega t. So when the phase difference between V and I is equals to omega t minus omega t. So the phase difference between V and I is 0. This show the V and I are in phase. The resistance of the resistor is given by R is equals to V0 over I0, and is equals to VRMS over IRMS, so that the resistance does not depend on frequency. So the graph of Z against F for resistor is in straight line. The blue one is the graph for Z against F. And now we look at the capacitor in AC circuit. So this one is AC signal, and here is current, AC current, and this is a capacitor. So the voltage, the potential difference between the capacitor is VC. So this is a Phasor diagram for capacitor. The current leads the voltage by pi over 2 radian. Okay, so after this we look at how the current is leads the voltage. The capacitor, AC waveform, and I and VC. So in the capacitor, Phasor diagram for capacitor, this is I, and the V is here, VC. So the current leads the voltage by pi over 2 radian. Okay, how we can get pi over 2 radian? So from this Phasor diagram, we project to the AC waveform. This is T, this one is V, and I against T. So the Phasor diagram will rotate and anti-clockwise. So first we look at the current. So when T 0, the current also 0, and then when T pi over 2, the current is maximum, and 0, and negative, and 0. So this one is the current. I is equals to I0 sine omega t. So for the voltage, when T0, the voltage is negative, and then we rotate anti-clockwise. So when pi over 2 here, and maximum 0, and minimum. So when we rotate here, we get this is a VC negative V naught cos omega t. So to get the equation V to sine equation, we must shift the axis to the right. So the equation will be V naught sine omega t. Okay, this one is pi over 2. So we want to be 0, so we must minus pi over 2 here. So this graph becomes sine graph, and minus omega t minus pi over 2. So from here we can get the equation, the phase difference between V and I. So omega t minus pi over 2 minus omega t. So we get negative pi over 2 radian. Therefore, it shows that the current leads the voltage by pi over 2 radian, or the voltage lags the current by pi over 2 radian. Okay, in capacitor, the voltage V lags behind the current by I by pi over 2 radians, or the current leads the voltage by pi over 2 radian. So the capacitive reactance in the capacitor is Xc. So Xc is equals to from the Ohm's law, Vrms is equals to Irms times Xc. So Xc equals to Vrms over Irms, or V naught over I naught. So V naught equals to V naught, and I naught is C V naught omega. It come from the previous slide. We get the I naught is C V naught omega. So we cancel V naught, and then we get the Xc is equals to 1 over omega C. So omega, we know that omega is 2 pi f. So we get 1 over 2 pi fc. So the capacitor reactance is defined as Xc equals to 1 over Xc, or 1 over 2 pi fc. So what is the graph? The graph impedance against frequency. So the frequency is inversely proportional to the Xc. So the impedance graph for capacitance is like this, inversely proportional to the impedance, inversely proportional to the frequency. Okay. Okay, conclusion for this subtopic. In the resistor, is R, in the capacitor is C, and the resistor is L. And this one is VR, I, VC, I, this one is VL. So the opposition, number 1, opposition offered by resistor it called resistance. The unit is ohm. And in the capacitor, opposition offered by capacitor equal reactance. The symbol is this one symbol is R, actually is R, and the symbol is XC is equals to 1/2 pi FC. Opposition offered by inductor, we call it reactance in inductor, reactance. So the symbol is XL 2 pi FL. So this one, when the frequency increase, XC will decrease. This one, when the frequency increase, XL will increase, directly proportional. So the graph here, impedance against frequency, so like this, and graph here, impedance against frequency, inversely proportional, and the graph here, impedance is directly proportional. And another thing, we know that current and voltage are in phase. Current leads the voltage. This one, voltage leads current. Okay student, now I want to show you apps which is we can see the Phasor diagram for each element. So we look at single element, we choose the single element for single resistor. So this the left side is the Phasor diagram and the right side is the sinusoidal waveform. So for example, here the voltage is 3 volt and the resistor is 100 ohm. And then you look at this, the blue arrow and the green arrow. So when we tap this here, the Phasor diagram is the blue one and the green one are in phase. So the Phasor diagram rotate in anti-clockwise. At the same time, okay, for the capacitor, single element, for capacitor, the current, the voltage, for capacitor, the current, okay, here also the current leads the voltage by pi/2 radian. So we look at this one. The phase difference between the resistor and inductor are pi/2. And for the single element, for single inductor also, the current lags the voltage by pi/2. Okay, that's all.